So before we begin our discussion on Lewis structure, let's talk about the elements we will and won't be drawing Lewis structures of. Typically, we're going to ignore most of the periodic table. This will be the transition metals with the D block. And when we look at the S block elements, typically we're ignoring the metals like lithium, sodium, beryllium, magnesium, and only focusing on hydrogen. And when it comes to the P block elements, we're going to be focusing on the top right corner. So the line mapped out from boron all the way down to iodine. So we'll be working with elements like carbon, oxygen, nitrogen, fluorine, iodine, chlorine, bromine, sulfur, phosphorus, selenium, and some of the noble gases as well.
Now when we draw a Lewis structure, each bond represents the sharing of two electrons. So if we had two carbon atoms sitting in space, each containing 4 electrons, the number of bonds we can form to each carbon is limited by the number of electrons it starts with. So if we have something like boron, boron is in the third column, 3A, contains 3 valence electrons, so we can only form 3 bonds with it, whereas something like nitrogen, which contains 5 valence electrons, can form 5 bonds. But our first bond is going to contain 2 electrons. Now this is what's called a single bond. Next, if we still have unpaired electrons between 2 atoms, we can combine them. So in this case, we can combine the top 2 electrons and form another bond. In this case, we'd have what's called a double bond. So now instead of having one line drawn between the two, we have 2 lines drawn between the two. And this line represents an additional 2 electrons being shared, so it's a total of 4 electrons. Now if we still have unpaired electrons, we can pair them up again. And we'll form what's called a triple bond. In a triple bond, we have 3 lines, each representing 2 electrons for a total of 6 electrons being shared between the 2 atoms. Now, in principle, you can go as high as doing 4 bonds. This would be a quadruple bond, but this is more when we start getting outside the elements we're limited to when we start doing Lewis structures in this class.
Also in our discussion of Lewis structures is going to be this idea of central versus periphery atoms. So if we look at a molecule like methane, methane contains the central atom as carbon, whereas it has 4 periphery atoms, hydrogen. Now the difference between a central atom and periphery atom is that typically a central atom is going to be connected to other atoms, whereas typically a periphery atom is the last atom in the chain. It only has 1 bond. So if we look at something like ethylene, C2H6, we actually have 2 central atoms in this case. We have 2 central carbon atoms, and we have 6 periphery hydrogen atoms. And so when we go to draw our structures, we typically start by drawing the central atoms first, and then fill in the picture with the periphery atoms.